All righty. So, y'all, 3.1, we're going to talk a little bit about probability. Okay. So, when we talk about probability, what do we mean by probability? Probability are things going to be like, look, I'm going to flip a coin. What's the chances or what's the probability that if I flip it, say 3 times, what's the probability that I'm going to get a heads every single time? That would be a probability problem. My wife and I are expecting a baby. We're not. But if my wife and I are expecting a baby, what's the chances that it's going to be a boy or a girl? What's the probability we're going to have twins? What's the probability we're going to have triplets, right? That's what we mean by probability, okay? So a probability experiment, y'all, it's an action, it's a trial through which specific results are obtained. Outcome in a probability experiment, an experiment is the result of a single trial. An event consists of one or more outcomes and is a subset of a sample space. And events are typically denoted using uppercase or capital letters, okay? And then the sample space is a set of all possible outcomes of a probability experiment. All right, so let's take a look at a particular problem that we got here. It says, look, for example, consider the probability experiment of rolling a die 1 time. So look, y'all, we got a picture of a die, right? When we were kids, if you played board games, Sorry and Candyland and all that kind of stuff, you probably rolled a die, right? So if you roll a die, y'all, when we roll it, that die can either land on a 1, 2, 3, 4, 5, or 6, right? There's 6 sides normally to a regular die, okay? So the outcome would be, say we rolled it and we came up with a 3. That would be an outcome, okay? The event of rolling an even number. Y'all, if we have numbers 1, 2, 3, 4, 5, 6, which ones are even? 2, 4, and 6, right? Those are what we mean by either a particular event or an outcome. You roll a die, you get a 3. You roll a die, you get a 5. If you roll a normal die like that, y'all, 6-sided die, could you ever get a 7? No, right? Because there's only 6 sides to it. Okay. Now there are some dice that have 10 sides to it. There's some that have 12 sides to it. But if it's a regular die, 6-sided die, you're never going to get a 7, right? Okay. Now, when we're watching the news, y'all, if you watch the news right at 6 o'clock or at 10 o'clock, and Ken Smith is getting mad at you because you don't know where McAllen is and you know where Michigan is on the map. But if he says there is a 65% chance of rain tomorrow, we want to know what is the probability that it would not rain. So, y'all, when we talk about probability is always going to be a number between 0 and 1. Okay. So, what I mean by probability is going to be between 0 and 1. If I were to flip a coin, y'all, if we flip a coin, do you guys agree that we can either get a heads or we can get a tails? Okay. So, how many outcomes do we have here? How many different possibilities do we have? 2. Okay. So, we have 2 outcomes. The probability that we get a heads, out of those 2 outcomes, how many of them are heads? Just 1, right? So my probability would be 1/2, right? What's the probability I'm going to get heads? It's either going to be a heads or a tail. So it's going to be a half, right? 50%. My probabilities, y'all, are either going to be a number between 0 or 1. Or if you think about them as percentages, between 0% and 1%. So y'all, if Tim Smith says that there's a 65% chance that it's going to rain, and we want to know what's the percent chance that it's not going to rain, what we would do is we'd say, look, the total percent is going to be 100. If it is going to rain, it's 65%. So what's the percent chance that it's not going to rain? And y'all, I'm just going to take my calculator, 100 minus 65. There's a 35% chance of no rain. Does that make sense? So it's either going to rain or it's not, right? If there's a 65% chance that it will rain, then there's a 35% chance that it won't. Okay. So, y'all, one of the things that we have here is this idea called the sum of probabilities. Okay. So, the probability that something's going to happen plus the probability that it's not going to happen is going to be equal to 1, right? Because again, 100%, right? Or 1. Or we say the probability that something's not going to happen will either be 1 minus the probability that it does. Okay? So I'm going to walk you through this question so we can think about what is this question asking me to do. It says the probability that an event will happen, P of E, is 12 out of 19 from the probability that it's not going to happen. Yo, let's make up a story so we can kind of understand what's going on here. Suppose there's 19 of you all sitting here, right? There's 19 of us sitting here, and we're going to elect a class president. And out of the 19 of us that are here, 12 of us want Paulo to be the class president. Okay, so what's the probability that Paulo's going to win? Out of the 19, how many people are voting for him? 12. Okay. So y'all, this part here says to find the probability that it won't happen. So what we want to know is if 12 people are going to vote for Paulo, how many people would not? So let's think about it like this, y'all. There is a total of 19 of us, right? Out of that 19, 12 of them, am I spelling it right? Oh, you, Elo? Okay, thank you. 12 of us want Paulo to be our class president. Can anybody tell me how many people do not want Paulo to be our class president? 7, right? 7. These are the rest of the people, right? Who do they want? I don't know, but they want to vote for somebody else, okay? So if the probability that Paulo is going to be our class president would be 12 out of 19, what's the probability that he won't be our class president? 7 out of how much? Out of 19. So y'all, it's still going to be it's still going to be a fraction here, okay? This is how we think about probabilities, right? 19 people total, 12 of them say, Paulo's our guy. And then there's another 7 that say, I don't know yet, right? That's all we're doing, okay? Y'all, I'm going to scroll down a little bit further, okay? I'm going to scroll down a little bit further. My next question here, look what it says. The probability that an event will not happen. So this is a probability that something is not going to happen. And y'all, the probability that it's not going to happen, I want you to look, we have this little E with an apostrophe. That little E with an apostrophe means it's that the event will not happen. So the probability of E means the event will happen. Then the probability of E with a little apostrophe is the probability of the event will not happen. Okay. So y'all, let's think about this for a minute. We just talked about our favorite weather guy in the whole world. Everybody loves Tim Smith, right? He's an icon in the Valley. Y'all, look what he's saying right here. Y'all, there's an 82% chance that it's not going to rain. So 0.82, that's the same thing as 82%. That means that there is an 82% chance, y'all, that it's not going to rain. If we wanted to figure out what's the percent chance that it would rain, remember what we did before? We said, look, let's take 100, let's minus 82. That's going to give me 18%, right? That's a probability that it will rain. But since we're doing this with decimals, what number would I put in that box? If it's 18%, anybody know what 18% is as a decimal? 0.18, right? Boom. And that's all we're doing. Does that make sense? Okay. So, y'all, next problem I got here in my list says identify the sample space of the probability experiment and determine the number of outcomes in the sample space. Okay, so let's take a look here and let's see if we can figure this part out. It says randomly choosing a number from the odd numbers between 20 and 30. So y'all, the first thing we're going to do, we're going to make a list of the sample space, okay? The sample space is going to say, can we write down all the odd numbers between 20 and 30? Everybody agree the first odd number would be 21? What's the next odd number going to be? 23, and then 25, and then And then, would we keep going? No, we'd stop there, right? Why are we going to stop there? Because we're only looking at the odd numbers between 20 and 30. Now, y'all, I want you to notice something on the direction. It says use a comma to separate the answers and write our numbers in ascending order. Ascending order just means write them from the smallest to the biggest, okay? So, y'all, if you write 25, 23, 21, 29, are you doing it wrong? You're not doing it wrong, but they want you to put them in the order from smallest to biggest, okay? Now, they're asking us to do a couple of things. They want us to identify the sample space. We just did. We wrote them out. The second thing is they want us to determine the number of outcomes. How many numbers did we write down? 5? 1, 2, 3, 4, 5. Very good. So the number of outcomes is equal to 5. All right. So, y'all, the next thing we have here is this idea called the counting principle. So what the counting principle says, it says if a first experiment can be performed in n different ways. Let's give the number. How many times can we do this? Or how many ways can we do this? Don't give us a number. And a second experiment can be done in n distinct ways. Then the two experiments in that order can be performed in n times n different ways. Okay, so y'all, in this next question, they're going to ask us to do a couple things. They're going to ask us to identify the sample space of the probability experiment and determine the number of outcomes, and then we're going to draw a tree diagram. So I'm going to show you, y'all, what I mean by all this stuff here. Okay. So look, if I come back and I look at my question, it says determining a person's favorite steak. So let's look at the different steaks that they're giving us here, y'all. We got a ribeye, we have a filet, we have a T-bone, and we have a sirloin. So we have a total of 4 steaks, okay? And we can cook those steaks either rare, medium, or well done. So we got 3 levels of doneness, right? Whether it's going to be rare, medium, or well done. So y'all, first thing we want to do, we want to find the sample space. So y'all, this is what I'm going to do. I'm going to say, look, I'm going to go to my first steak. I'm going to use the letter R because that's what they got right there. We can get a ribeye. We can get that ribeye, y'all. We can either get that ribeye rare, we can get that ribeye medium, or we can get that ribeye well done. Okay, we've done the ribeye. We can get a filet. We can get that filet rare. We can get the filet cooked medium, or we can get the filet cooked well done. Okay, we've used that one. We can get a T-bone. We can get that cooked rare. We can get that cooked medium, or we can get that cooked well done. Okay. And then we have another option. We can get a sirloin. We can get that done rare. We can get that done medium, and we can get that done well done. Okay. So this here is what we call our sample space. Okay. We want to know how many different options do we have here. Y'all, if we were to count each of these combinations, how many would we have in total? 12, right? We got 12 in total. Remember we said, look, we got 4 steaks and we can get them cooked in 3 different levels. We're going to have a total of 12. So 12 is going to be the number in my sample space. Now, y'all, there's something called a tree diagram. A tree diagram just gives us a visual of what's going on, okay? So if I come back over here and I say, look, let's take a look at each of the steaks. We had 4 different steaks, y'all. So I'm going to make a little thing that's going to look like this. It's going to have 4 pieces, okay? One of them is going to say a ribeye. One of them is going to say a filet. One of them will say a T-bone. The other one's going to be a sirloin. Those are the 4 different steaks that we can get. Now, y'all, we can cook those steaks to 3 different levels, either rare, medium, or well done. 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 Okay. Now, y'all, one thing I want to mention, when you're doing your homework in Pearson, when it comes to doing the tree diagram, y'all, it's gonna be multiple choice, and they're gonna give you some options, and you're gonna just pick the right one. Okay, you're not actually gonna have to on your computer draw these sticks and stuff like that. But that's basically what you're looking at. It's just showing you these are my 4 different steaks, and then from each steak I can cook each one of those 3 different ways. It gives us a visualization. Okay. Now, the reason why we do stuff like this, y'all, one of the reasons why we do stuff like this is if we said, look, we got a steak. What's the probability? We could ask ourselves certain questions. We could say, what's the probability that we got a sirloin cooked rare? And what we would say is, look, there was 12 options, and a sirloin cooked rare, that was one of the options, 1 out of the 12. You see what I'm saying? And now you can kind of do this, and you got a visual of how we can start doing some probability type stuff. Okay. Y'all, I'm going to continue to scroll down on my list. Okay. And we're going to talk about something called a simple event and something that's not a simple event. So a simple event is an event that has only one outcome. So, and it says, if an event consists of more than one outcome, then it's not a simple event. Okay, so it says decide or determine the number of outcomes in the event, decide whether it's simple or not. Question? I'm sorry, I thought I heard something. It says, look, a computer is used to randomly select the number between 1 and 9 inclusive. Okay, event A is selecting the number 4. So if we're gonna pick a number between 1 and 9 inclusive, y'all, what event A is picking the number 4? If I look at my numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9, but we picked the number 4, it has one outcome, right? It's got one outcome right there because we picked the number 4. All right. Determine the number of outcomes in the event. Decide whether the event is simple or not. You randomly select 1 card from a deck of standard deck of 52 cards. Event A is selecting a 10 of spades. So y'all, let me pull something up here for you guys because I'm not confident if everybody knows what a deck of cards looks like. So y'all, in one of the other classes that I teach, we do some of this statistic stuff or probability stuff. And one thing that I learned is that over the years, let me see, where's my folders? Looking for like that. Here we go. Here we go. Contemporary math. Let's pull this guy up here. Let me see if I can scroll down. We should have a picture of a deck of cards. I don't know what's in there. Sorry. Look for this thing. Here we go. Deck of cards. Okay. There we go, y'all. There's my deck of cards. One thing I learned is when I was a kid, I was growing up, I played with deck of cards all the time. I played my own kind of stuff, or at least watch them. But I know not everybody has a whole lot of experience with it. So, y'all, here's my deck of cards, right? If I'm looking at my deck of cards, and I think the problem said something like we're going to pick a 10 of spades. If I look at all of these cards, y'all, how many are there 10 of spades? Just how many? Just 1, right? So, y'all, we got a simple event because there is only 1 10 of spades. Okay, so I'm going to go like this, 1 outcome, and it's going to be simple because we got a 10 of spades. Yeah, because we're just right now we're just looking at the total number of options that we got. It's just 1, yeah. We'll start doing some more of the probability stuff in a little bit. Y'all, let's take a look at the next question here. It says a restaurant offers a $12 dinner special that has 4 choices for an appetizer, 11 choices for an entree, 3 choices for a dessert. How many different meals are available when you select an appetizer, an entree, and a dessert? So again, y'all, this is basically just using the counting principle. There's a number here in this problem, guys, that I don't need to use. That number, the number 12. So if we're going to pick an appetizer, how many appetizers can we choose from? 4. Okay. Now we're going to pick our entree. How many options do we have from our entree? 11, right? Okay. Now, how many choices do we have for our dessert? 3. So y'all, this is going to tell me the total number of possibilities we can get. We're going to go 4 times 11 times 3. There's 132 options here, y'all. What that tells me, there's basically 132 different combinations. Okay. All right. The next one, y'all, says a realtor uses a lockbox to store the keys to a house that's for sale. The access code for the lockbox consists of 5 digits. The first digit cannot be a 4, and the last digit must be odd. How many different codes are available? Okay, so let's take a look here, y'all. We have a lockbox that has a code on it, and it has 5 digits. So look, y'all, I'm going to go like this. That's the first digit, that's the second, that's the third, and that's the fifth. Okay, so when I'm thinking about my digits, y'all, I'm just thinking about regular numbers. What I mean by regular numbers: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. How many choices do I have here? Anybody know what's the total number of numbers that we got in that list? 10. There's a total of 10 options, y'all. Okay. Now, notice what they tell me about the first digit. The first digit cannot be a 4. So, y'all, in this first box, I know I cannot pick 4. So if I don't pick 4, how many numbers can I still pick? Everybody agree 9? Couldn't we still pick 9 different numbers? We're just not going to pick what number. For the first spot, we can't pick a 4. For whatever reason, we can't pick a 4, so we're not going to pick it. So we got 9 options now, right? Okay. Now, they didn't give me any other restrictions except for the last digit. So in the second spot, y'all, we can pick 10 numbers here. In the third spot, we can pick 10 numbers here. In the fourth spot, we can pick 10 numbers here. Now, it does say that the last digit has to be an odd number. Y'all, let's circle the odd numbers. These numbers here, y'all, are odd. How many odd numbers did we circle? 5. This, y'all, when we start to multiply, is going to tell us all the different combinations we can make for our lockbox. So I'm going to grab my calculator again. I'm going to clear this out and go 9 times 10 times 10 again, times 10 again, times 5, 45,000. Y'all, there's 45,000 different options on that particular lockbox. All right, y'all, as we continue to do this, again, I just want to kind of make sure that everybody's good with what we're doing here. Are we good on why we could only pick 9 numbers here, why we could pick 10 there, and only 5 here? Is that making sense? Okay, just checking with everybody. So y'all, like on your phone, everybody, for the most part, we have like a passcode on your phone, right? Some of us have a 4-digit passcode. Some of us have a 6-digit passcode. But that's basically, you're just figuring out how many, all the different ways. Or you have your bank card, right? Your ATM, what's your PIN? Most of us have 4-digit PINs, right? It's really hard for somebody to figure out what your PIN is because you got a whole lot of combinations there, right? Okay, so again, y'all, I'm still here just looking at total number of options. Okay, we're going to start talking about probability in a second, but it says, assuming that no questions are left unanswered, in how many ways can a 5-question true-false quiz be answered? Okay, so let's go like this, y'all. Let's go really slow. How many questions do we have on this quiz? 5. Okay, so look, y'all, I'm going to go 1, 2, 3, 4, and 5. And this kind of a quiz is a what? True-false quiz? Okay, so every question is either going to be true or it's going to be false. So my first question, y'all, how many choices, how many different options do I have to answer? 2, true or false. My second one, we still have 2, right? My third one, we still have 2. Our fourth question, we still have 2. And our fifth question, we still have 2. So y'all, all we're going to do is count, right? I'm going to take my calculator here and go 2 times 2 times 2 times 2 times 2, 32 ways. The quiz can be answered in 32 different ways, right? That's how we can answer that quiz, just by doing true false stuff, okay? Because every question can either be true or false. So we got 2 options for each. All right. So talking a little bit about probability, y'all, it says here, we're going to talk about something called classical or theoretical probability. It's used when each outcome in a sample space is equally likely to occur. The probability for a particular event, E, is denoted by P of E. All right. And the way we're going to figure that out is going to be the number of outcomes in the event E divided by the total number of outcomes in the sample space. So let's take a look at what's going on here. It says a probability experiment consists of rolling a fair 12-sided die numbered 1 through 12. Find the probability of the event below. So y'all, one thing I want you to notice about this problem is that they said that our die has 12 sides. So when we roll that die, y'all, these are the options that we can end up with. We can get a 1 through 12. So y'all, when we're going to find the probability of rolling a 1, we're going to say, look, there's a total of 12 possibilities. Y'all, out of those 12 possibilities, how many of those numbers are the number 1? Just one of them, right? 1 out of 12. Okay. Now, y'all, when you notice here, it says write an integer or a decimal. So we have a fraction. We're going to convert that fraction to a decimal. Y'all, I'm just going to go with this 1 divided by 12. And we're going to round to 3 decimal places. So y'all, if we round to 3 decimal places, what do you guys think? 0.083 or 0.084? 0.083, right? Boom. So right here, y'all, we're going to put 0.083 and we're done. Y'all, my next one here says, look, a probability experiment consists of rolling a fair 10-sided die numbered 1 through 10. So y'all, I'm going to do the same thing here. I'm just going to make a list of the numbers that we're able to get when we roll that die. Okay. So a fair 10-sided die, those are my options. Okay. So look, y'all, when I'm going to do this, it's going to be out of 10. Now, the question is asking me, what's the probability that we're going to get a number that's bigger than 3? So if I look at my numbers here, everybody agree that these are the numbers that are bigger than 3? How many numbers are bigger than 3, though? 7, right? So y'all, we're going to do the same thing because, we're going to do the same thing because they are asking us to write a decimal. So y'all, I'm just going to take my calculator. I'm going to say, what's 7 divided by 10? 0.7. And we can't really round to 3 decimal places if we don't have 3, right? So we're just going to write 0.7. All right. Y'all, I'm going to keep going down my list. Okay, so the other type of probability we talk about, y'all, is something called empirical or statistical probability. And that's based on the number of observations obtained. So y'all, when we're doing something like empirical, and I'm going to see if I have anything. I'm an old man, so I keep my change in my wallet because I'm old already. Okay. But, and I know those of you who are home can't see me right now, but I got a quarter in my hand, okay? So y'all, if we were to flip this quarter, we know we're going to get what? Heads or tails? Okay. Let me ask you guys a question before I go into this problem, and I'm going to try to do something here too, y'all, real quick, just so that the folks who are at home can see if I can do this. Is it going to work? There we go. Okay, so the folks at home can see too, y'all. If I have a quarter here, I'm going to come back here because I think they can still see if I do this. Boom. Um, we're either going to get heads or tails. If I were to flip this quarter 10 times, do you guys think that on average, 5 times we should get heads and 5 times we should get tails? In theory, would that make sense? If it's going to be either heads or tails, we're going to do it 10 times. It would make sense that 5 is heads, 5 is tails, right? Does that mean that's exactly what's going to happen? Not always, okay? So look, I'm going to flip it, tails. So guys, can somebody do me a favor? Can somebody keep a tab? So far we flipped it once, we got tails. Okay, oops. Let me flip it again. Tails again, okay, that's twice. Tails again, that's 3 times. Heads, that's 4. Tails, that's 5. Theoretically, the next at least 4 should be, right, heads and whatnot. Oh, sorry about that. Here we go. Boom, let's go like this. Boom, tails again. Heads. Tails. How many is that? 6. Heads. That's 7. Okay, 8. Tails. Is that 9? That's 9? Okay. And heads. Okay, so guys, how many heads and how many tails did we get? Anybody know? 3 heads. So heads. What did you get? Did anybody else get something different? Okay, 4 heads and so 6 tails. Okay, so theoretically, y'all, we said we should get half and half, right? We should get half and half. We got almost half and half, right? We got almost half and half. Yo, if we were to do this, say we did it 10 times, right? If I were to ask you, what's the probability that we got a heads? We would say, well, look, we got 4 heads out of 10, and we could take our calculator, right? We can go 4 divided by 10, and we would say the probability is 0.4. We know that in theory, the probability is really 0.5 because it's half and half. But this is what we call empirical probability. We did the experiment ourselves, and these are the numbers that we got. Now, empirical probability, y'all, is going to be based on the numbers that we have, not necessarily what it ideally should be, okay? Now, y'all, there's another thing called the theory of large numbers. And so if we were to say flip that coin, instead of 10 times, if we flip that coin 100 times or 1,000 times, say we did 1,000 times, we should get closer to 500 and 500, right? But we did it just 10 times. So let's take a look at what we got here. It says a company is conducting a survey to determine how prepared people are for long-term power outage, natural disaster, or terrorist attack. The frequency distribution on the right shows results. Use the table to answer the following question. What is the probability that the next person of the survey is quote unquote very prepared? Okay, y'all, first thing I need to do in doing this problem here, I need to figure out what's the total number of people that we surveyed. So y'all, I'm just going to grab my calculator right here, okay? And we're going to say 240 plus 947 plus 582 plus 328 plus 61, okay? So y'all, I'm coming up with a total of 2158. Okay, that's the total number of people. Now, we're looking for the probability that the next person is very prepared. Out of those 2,158, how many of them were very prepared? So we're going to take, y'all, to find our probability, we're going to take 240 and we're going to divide it by 2158. And we're going to go ahead and go to 3 decimals. That's what it says here. What do y'all think? 0.111, right? So 0.111, and there we go. Okay, and that's how we can find our theoretical probability. So y'all, I can't just write this number down, right? Probability is always going to be a decimal. It's going to be a number between 0 and 1, right? Stuff like that. So it can't be 240. but 0.11 or 0.111 is the number between 0 and 1. Let's try the next one here, y'all. It says, use the frequency distribution, which shows the number of American voters in millions according to age, to find the probability that a voter chosen at random is in the 18 to 20-year-old range. Okay, so look, y'all, let's find again the total number of voters. So again, y'all, I'm going to grab my calculator here, move this over, let's clear that out. We're going to take 5.5 plus 8.4 plus 22.1 plus 25.4 plus 51.4 plus 28.1. So y'all, I'm coming up with 140.9. Okay. And now we're looking for the probability that the voter is in between the 18 to 20-year-old range. So I'm going to take 18 to 20 is 5.5. And we're going to divide that by 140.9. And again, y'all, if we go to 3 decimal places, what do y'all think? 0.039 or 0.04? What do y'all think? Remember, we got to have 3 decimal places. So let's blow this up so we can see a little bit better. We got to make sure we have 3. So my question to you all, if I'm looking at this, should I round that 9 up? What tells me if I should round the 9 up, y'all? The number to where? To the right of it. Okay, if that number is a 5 or more, then we'd have to round this guy up. But it's really a what? A 0, so we're going to write 0.039, right? Good. Awesome, y'all. 0.039, boom. And we got our probability. All right, guys, I'm going to scroll down just a little bit more because I think there's one last question here, y'all, in 3.1. And this problem here says, let's use, again, the frequency distribution to the right, which shows the number of voters in millions, to find the probability of a voter chosen at random is in the given range. And y'all, I want you to notice something here. It says they are not between 45 and 64. All right, well, let's still do the same thing. Let's go ahead and find the total again. And I think my numbers are different, so I got to do this again. 5.3 plus 11.6 plus 22.7 plus 27.2 plus 53.7 plus 25.3. So y'all, I'm coming up with my total to be 145.8. Okay. So y'all, if it says we want to find the probability that the person is not between 45 and 64, okay, not, so we're looking at not that group. Does anybody have an idea of how we could do this? Subtract what? I'm sorry. I agree, subtract. Okay, so tell me what numbers you'd want me to subtract. Okay, so let's subtract 53.7 from here. And then we're going to get 92.1. And we're going to divide that by the 145.8. Okay, so let's divide that by 145.8. And what do you guys think? 0.631 or 0.632? What do y'all think? 1 or 2? What do y'all think? 2, right? Why? Because that guy's a 6, so it's got to round that guy up, right? So 0.632. So 0.0, or is it 6? Or no, 0. Yeah, 0.63. 0.63. Oops, sorry. 32. Boom. So y'all, definitely, I agree. Perfect. That worked out great. Just subtract that number from the rest, right? So really what we did, y'all, was we could have said, look, we could have added all these numbers up, right? But he said, look, instead of me adding all those numbers up, I know when we add them all, we get this. So let's just remove this guy And that tells me what all the other ones added up are, right? Y'all, another way we could do it, we could take 53.7 and we could divide it by 145.8. And look what number I'm coming up with. I'm coming up with 0.368, right? Now remember, this is a probability that we don't want. So what we could do is we could say, let's take 1 minus 0.368, and isn't that the same answer that we came up with, right? So remember what I said before, like if Tim Smith says, hey, there is a 65% chance it's going to rain, what's the percent chance it's not? So if that meant that there was a 0.368, right, probability that it was going to happen, what's the probability that it's not? Let's just subtract it from 1 and you get the same answer. Okay. All right. So y'all, that right there is 3.1. I'm going to just do a tiny bit of 3.4, like literally 15 minutes at most of 3.4. So I'm just going to scroll down in the list. We will pick up the rest of 3.4, y'all, next Tuesday. And when I'm done with this, again, it'll be about 15 minutes, y'all. I'm going to talk to you guys about the test. And then anybody who wants to hang out afterwards and work on homework, guys, I'll be here to help you guys out. Okay. So let me just talk. Yes. Yeah, it should be recording. Yeah, we're recording. Yeah. Thank you. But thank you for double checking. Because then otherwise I got to sit down and do it all over again, right? All right. Guys, 3.4, additional topics in probability and counting. Y'all, there's something called a permutation. Okay, permutation is an ordered arrangement of objects. And there is like a little formula here, y'all, we have for permutations. And the formula for a permutation, y'all, right here, it looks like this. It has a number with an exclamation point. And it doesn't mean that I'm yelling out that number like in English when you put an exclamation point, right? Like hello, right? That's not what it means. I'm not yelling the number 7. What this means is that we're going to take that number and we're going to start subtracting 1 each time, and we're going to go all the way down till we get the number 1. We're going to multiply. Okay, so let me just explain what I mean by this. If I were to say, what's 5? We call this factorial. If we have 5 factorial, that means we're going to go 5 times 4 times 3 times 2 times 1. That's what the definition really means, okay? Doesn't mean I'm yelling out the number 5. It just means I'm going to go 5 times 4 times 3 times 2 times 1. Okay, so look, first problem here, y'all, says we have 11 different video games. And how many different ways can we arrange those games side by side on a shelf? So y'all, what I'm going to do here is I'm going to put little spaces where I'm going to put all of those video games. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, we got 11 games. So y'all, when we're going to put those games on the shelf, the first time we're going to put a video game, how many games do we have in total? 11, right? So in the first spot, y'all, we have 11 choices to put. Now, we put one of those games there. Now that we've picked one of those games, how many choices do I have for the second spot? 10, right? And once I took that game out, in the third spot, y'all, I got 9 choices. And the next one I have 8. And the next one I have 7, 6, 5, right? 4, 3, 2, and 1. And all I'm going to do, y'all, is multiply those numbers out. Now, y'all, on our calculator, right? And I'm talking about the calculator like the one like this. Here we go. We have a way to do this without you having to, go 10 times or 11 times 9, all that kind of stuff. So the first thing we're going to do, we're going to type the number 11. And then right here, guys, on my calculator, there's a button that says math. I'm going to hit that button. And up here at the top on the far right, it says PRB. So y'all, a couple of ways you can get there. You can go 1, 2, 3, like that. Or if you were here to begin with, just go 1 to the left and you're at PRB. Sorry. 1 to the left and you're at PRB. I want to hit number 4 because number 4 has that little exclamation point. So you can either hit the number 4 or you can scroll down and hit enter. And then notice it has 11 with an exclamation point. Hit enter again. And the number of ways that this can happen is 399, 16, 800, 399, 16, 800. And that's all the different ways that you can arrange all those different video games on the shelf. All right. So, y'all, I'm going to scroll down a little bit further. I'm sorry. Question? Yeah, of course. So, y'all, I'm going to go to my calculator here. First thing I'm going to do, I'm going to type 11. I'm going to hit the math button. And right here where it says PRB, you can just hit the little arrow button, 1, 2, 3. And then you're going to scroll down to the fourth one, or you can even type in the number 4 because that's where the exclamation point is. So if you hit the number 4, it does it for you, and then just hit enter again. And you got it right there. And y'all, it works the same way on the apps too, right? So if you're using one of those calculator apps, it works the same exact way. But that's really what you're looking for. You're looking for that little exclamation point to tell you how you can find those numbers. Good question. Good question. All right, y'all, let's take a look at the next one here. It says outside of a home, there's a 5 key keypad with the letters A, B, C, D, and E that can be used to open the garage door to deliver a 5-letter code entered. Each key may only be used one time. How many codes are possible? So look, y'all, we're going to do a 5-letter code. So I'm going to go like this. 1, 2, 3, 4, 5. The letters that we have to choose from, y'all, are these letters right here. Okay. So let's think about this. In the first spot, how many letters can we choose from? 5. Okay, look, y'all, if we chose a letter, I'm going to make this up. Suppose we chose the letter C. How many choices do I have now? 4, right? Suppose we chose the letter A the second time. How many letters can we choose from now? 3, right? Boom. And then we got 2 options, and then we have 1 option. So again, y'all, I'm going to do the same thing that we did before. I'm going to use my calculator. I'm going to hit 5. I'm going to go to math. I'm going to go to the PRB, and I'm going to hit number 4, and I'm going to hit enter, and there should be 120 different options, right? Okay, so y'all, just to give you an idea here, just so we get like a visual. 1, 2, 3, 4, 5. Okay, one option we could do, the real kind of plain one, right? Probably the default code would probably be enter A, B, C, D, E, right? But, you know, it's like 1, 2, 3, 4 is your pin, right? I hope nobody has 1, 2, 3, 4 as your pin. But, you know, what you're really looking at is, could you put C here, and then A, and then E, and then D, and then B, right? Something like that. That's your code to open up the garage door. But again, you have 120 different options here. Okay. So y'all, there's another thing we're going to talk about is when we have a certain number of objects and we're going to pick a particular number. So like if we have n objects and we're going to pick 5 of them, if we have 15 objects, we're going to pick 2 of them. How can we do that? So let me show you by an example how we make this thing make sense. Look what it says here, y'all. There's 53 runners in a race. And how many ways can the runners finish first, second, and third? Okay, so we're looking at picking people who are going to be first, second, and third. So y'all, look, first, second, and third. Okay. How many runners did we have in total? 53. So for the first place, there are 53 people who can win first place. But once you win first place, we're going to take you out because you're not going to win second place too, right? So now, how many people can we pick for second place? 52. How many about for third place? 51, right? So look, y'all, a couple of ways you can do this. One way you can do this is you can say 53 times 52 times 51, and we're coming up with 140,556. Okay. Or the other way we can do this, y'all, what was the total number of runners that we had? 53. And we're going to pick how many different positions? 3. Y'all, I'm going to show you how you can do this on your calculator. Whichever way you want to do is easier. And there's no one way is better than the other. So look, y'all, if I clear out my calculator, I'm going to go 53. I'm going to hit the math button again. I'm going to go to where it says PRB. And if you look at number 2, do you see how number 2 has the P? Because we're picking our places. So look, y'all, I'm going to scroll down or hit number 2. The number I'm going to select now is the number 3. And I'm going to hit enter, and I'm getting the same exact answer. Okay. Now, y'all, I noticed on some of the apps, because on one of the apps that I used before, what I have to do is go to the PR, the NPR thing first, and what it does is it puts 2 little boxes here, and then you got to kind of scroll back, and in the first box you're going to type in a 53, or yeah, 53, and in the last box you're going to type in a 3, and then you hit enter. But that would be the other way you can do it. I kind of like doing it. I'll get rid of the calculator right now so you all can see. I kind of like doing it like this because I think it just makes a whole lot of sense. How many people can win first place? 53. Once somebody wins, now there's 52 people. When somebody wins, now there's only 51. Okay. But again, either way you do it, it's the same thing. Yo, I think I got another one like that. And then again, we'll do one last problem, y'all. We'll stop right here, and then we'll call it a day, and I'll talk to y'all a little bit about the test. So y'all, here's my next question. Again, it says an archaeology club has 53 members. And how many ways can they select a president, vice president, treasurer, and secretary? So look, y'all, we are picking 4 positions. So there's 53 people who can be the president. Now there's only 52 people to choose for the vice president. There's only 51 people to choose for the treasurer. And there's only 50 people to choose from the secretary. And we'll go 53 times 52 times 51 times 50. And I'm coming up with 7,027,800. Right? And again, y'all, if you wanted to use the calculator, you would go like this, 53, and we're going to pick 4 positions. So again, I'd go math, PRB. I'm going to select the second one. I'm going to pick 4 positions here and same exact number, right? Whichever way you want to do it, all means the same thing. Okay. So, y'all, last question we'll do here. And again, we'll pick up the rest of it next week. And I'll talk to you about what we're going to do next week. We'll talk about the test, all that kind of good stuff. So let me kind of look through this question first, y'all, and then I'll come back and show you what the idea of the formula here is. Look what they're asking us to do here. They're asking us in how many different 10-letter words, real or imaginary, so basically just arrangements of those letters, can be formed from the following letters: Q, X, Q, F, H, I, X, O, L, and L. Okay, so y'all, remember the problem we had before with the keypad to the garage door? And we had these letters here, and we were making different combinations, right, or different arrangements of that. So we said, look, we can go E, we can go A, we can go B, we can go D, and we can go C, right? We can do something like that. We're basically doing the same thing here. The difference here, y'all, not so much that there's 10 letters here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, not so much that there's 10 letters here, y'all, but when I put this Q here, and then I put this Q here, if I switch those 2 Qs, would it really look any different, or would it be the same? You see what I'm saying? Because I got the letter Q twice, right? Or we have the letter X twice, right? So who's to say this is the first X right there, and that's the second X right there? We wouldn't know, right? Because they're the exact same letters. So the way we do this, y'all, is we ask ourselves, what's the total number of letters that we have? And they told us already, we had a total of what, 10 letters? Okay, so look, y'all, on the upstairs, we're going to have 10 letters. But then what we're going to do is we're going to count all the letters as we go across. And if it's the same letter, we're going to put those numbers kind of on the bottom. Let me show you what I mean by this. I'm going to come back over here and I'm going to say, look, how many Q's did we have? So we're going to put 2 factorial on the bottom. Those took care of my Q's. How many X's did we have? Okay, so down here, y'all, we're going to put 2 factorial. Did we have any other doubles here? The L's. So look, right here, y'all, we're going to put 2 factorial. Now, all the other letters, y'all, F, H, I, and O, there's only one of them, right? So we're going to go 1 factorial, 1 factorial, 1 factorial, and 1 factorial. So if I were to add 2 and 2, that's 4, 6, 7, 8, 9, 10. Okay, I got all my 10 there. And what I'm going to do, y'all, is I'm going to do this on my calculator, and I'm going to just simplify the whole thing. So look, let me show you how I would do this on my calculator. Y'all, I would first go open parentheses. I type my number 10. I'm going to go to math over here. I'm going to go to my PRB. Remember which one we want to hit, right? We want to hit 4. Okay, so let's do that. Let's close that off. Now, y'all, we're going to go divide. And I'm going to open up some parentheses. Now, y'all, I'm going to start entering my numbers in. So I'm going to go 2, math again, probability. I'm going to scroll down to number 4, hit the factorial, times, and I'm going to do that all the way across. Now, y'all, I'm going to give you a little hint in a second. As I start to do this, okay, 2, math, probability, scroll down to number 4. Okay, as I start to do this, little quirky here, y'all, you can ignore the one. Why don't you ignore the one? 1 factorial is the same thing as the number. So what happens when you multiply by 1 on the bottom? Stays the same, right? When you multiply by 1, nothing really changes. So once you do this calculation, this is going to say multiply by 1, multiply by 1, multiply. When you multiply by 1, nothing changes. Right? Your box says, hey, you're doing great. I'm going to take this out and multiply by 1. You can ignore all those ones. So y'all, right here, I'm going to close my parenthesis right there, and I'm going to hit enter. And what this is telling me is how many different ways can we arrange all those letters up there, y'all? 453,600. 453,600 ways. All right. Yes, question? No? Okay. Guys, what I'm going to do real quick, let me come back here. I'm going to stop hitting record since we're going to be